Hey guys, in today's video, I am going to show you how you can perform double, triple and single integration with only one line of code in Python. So without further ado, let's start the video. So this is the notebook that I have opened in Google Colab. We are going to look at three types of integrals. The first one is single integral when there is only one dimensional integrals. The second one is double integrals when there are two dimensional integrations. And the third one are triple integrals when there are three dimensional integrals. So, what's the theory? The theory is that there is an upper limit and a lower limit for every integral because we are going to talk about the limit integrations. There's a function right here. After the tedious calculation in mathematics, we always get a result as well as an error. UL demonstrates upper limit and LL means lower limit. Moving on to double integrals. This is the outer integral. This is the inner integral. As you can see, outer upper limit, outer lower limit, inner upper limit, inner lower limit. There's always a function inside each integral on which we are going to perform the integration. So this factor is common in all three types, and there is always a result as well as an error. The third one is called a triple integral. In this we have three integrations being performed on a function. The most outer one is called outer upper limit and outer lower limit integral. The middle one is called MUL or MLL, which is known as middle upper limit as well as middle lower limit integral. And then there is an inner integral right here with an inner upper limit and an inner lower limit. There's always a function on which all these integrations are going to apply. So the thing that is most cool about our program is that we will only write one single line of code majorly. If I give you a sneak peek, this single line of code will calculate all the mathematics behind an integration. Then if we come down to double integration, this single line will handle all the calculation behind the double integration. So forget about many different sort of calculations being performed in the backend. That's why we are going to use Python and we are going to use programming just to simplify our processes. Now coming down to libraries. We have three types of libraries that we are going to use in this video. The first one is called SciPy. So SciPy is the most common one that is going to integrate the single integration, double integration as well as triple integration. The second one is Numpy. So what Numpy does is we can import different logarithmic functions like log, sine, infinity and exponential. And by using SciPy, we can calculate indefinite integrals. So what are basically indefinite integrals? Are those types of integrals that give answer in the form of x. So those have no numerical answer. If we see here, these are definite integrals. These give us proper answer in numericals. And these are definite integrals. Now, what do I mean by indefinite integrals? So these are indefinite integrals. These give us answer in the form of variables and not constants. So let's run our code blocks cell by cell. So our libraries are installed. Now we are going to import these modules. So I will hit run. So all these modules are now imported. Now here, what does scipy.integrate mean? So basically there is a module named integrate in a scipy library. Okay, so we are importing this out of all other libraries. There are other modules as well, but we only need integrate to perform integration. We import quad, dbl quad and tpl quad. As the name suggests, quad is basically for single integration. dbl quad is basically for double quadrilaterals. tpl quad means triple quad. This is basically for triple integrals. For sine, logarithmics, infinity and exponentials, we are going to import numpy because we are going to see these cases as well in this video. For indefinite integrals, we are going to import SciPy. So I am going to write for indefinite integrals. Now let's move on to our number one. Here we are going to solve this problem where there is an upper limit of 1 and a lower limit of 0 alongside the function. Remember, this is function that is written closely with dx. So this is function, x square is function right here, and we get an answer after applying this integration. After doing all the mathematical steps, we get 0.33 as a result, and this is our error. Now just gonna import quad. After the import is done, I'm gonna run this function. So what this function does is that it performs x square and returns x square. So let's run this. Now for performing integration, as you can see here, lower limit is 0 and upper limit is 1. Based on this, we can apply quad on this function alongside passing lower limit as well as upper limit, and we will get our result. So here's the result: 0.33 plus minus 3.70 into 10 raised to the power minus 15. E minus 15 represents 10 raised to the power minus 15. Now moving on to the next problem. We have another single variable definite integral. So this is a complex problem. So first we are going to import the quad function. We are going to return the function over here. So this function, we are going to store its value inside integrand another. For integration, here we pass the function, here we pass lower limit and then upper limit. Lower limit is 1, upper limit is 2. Running the results, we are going to get the correct answer. As you can see here, 1.19 plus minus 1.32 into 10 raised to the power minus 14. So here you can see here the answer is correct. Coming down to next problem here, using common functions. So common functions mean logarithmic, sine functions, these types of functions. Log into sine of x. So basically this is the function. Perform integration. As we know, the lower limit is 0, upper limit is 2, and the result is this. Integration is basically function, lower limit, upper limit. Let's run it. The answer is correct. Moving on to next one. So here there is a challenge. There is infinity sign. So how we are going to handle infinities? So in Python we have something called INF in Numpy. So INF represents infinity, and here E is basically exponential. So exp is also present in NumPy. So we are going to use NumPy for this. Now running the function exp minus x, and then here's defined the lower limit and upper limit. Let's test the result. So basically 1.0 and 5.84 into 10 to the power minus 11. So our answers are correct. Moving on to single indefinite integrals. So basically single indefinite integrals are integrals without limits. What we are going to do is that we are going to make use of SymPy, importing symbol and integrate. First we define what sort of symbol we have. We have x. Basically this is x. Now moving on to integration. So basically we define a variable. We call this integrate x square x. So basically it performs integration on x square with respect to x. And our answer is x cubed divided by 3. You can see here x cubed divided by 3. Plus c is basically constant, so it doesn't matter. Now indefinite integration of sine x. So yes, minus cos x is our answer. As you can see here, minus cos x. If you want this plus c to be seen over here, you can just write it like this, plus c. So here you can see all the result here. I will also add the plus c over here as well. X cubed by 3 plus c, and here this one minus cos x plus c. Now moving on to double integrals. Here, as you remember, I mentioned that there is an outer upper limit and there is an inner upper limit, inner lower limit. So outer integral, inner integral. So that's the concept that we are going to use in this integration, double integration. So basically first import dbl quad, that will perform double integration. After that we are going to define the function, that is xy square. So basically returning simple xy square here. After that we are going to perform integration here. So for integration we are going to define 4 variables here. First one named as inner lower limit, that is 0. Inner lower limit, that is 0. Then inner upper limit, that is 1. Outer lower limit, that is 2. Outer upper limit, that is 4. Now the result. Here you can see some lambdas over here, right? So lambdas are nothing. Just remember the concept, whenever there are more than one integrals involved, like in double integration and in triple integrations, then all the outer integrals will get lambda with them to get the correct answer. So here that's why we have added lambda x to get the correct answer. And here you can see for with the inner upper and inner lower limit, we didn't add lambda keyword because we didn't need it. Right now we want to perform double integration, that's why we are placing lambda with respect to outer limits. All right, 9.33 plus minus 2.06 into 10 to the power minus 13. The answer is correct. Moving on to triple integration. Now for triple integration, there is an inner integration, there is a middle integration, and there is an outer integration. Remember I said that for double and triple integration, we need to have lambdas with all the outer integrals. So only one single inner integral will have to the point upper limit and lower limit. All the outer ones that are middle and outer one, those will have lambdas involved with them. So first run this, importing triple quadrilateral, defining the function here, z multiplied by x plus y plus z. All right, this is basically simple multiplication multiplied by x plus y plus z. Now integration, we have defined all the 6 variables for inner, middle and outer, upper and lower limits. After that we need to just pass them. So yes, as you can see, we've got the result here, 2.83 plus minus 3.69. Yes, so this is the result here. I hope you've understand the concept about how you perform integrations in Python and how you can leverage the one single line of code to perform single, double and triple quadrilaterals. If this video has helped you in any manner, make sure to subscribe the channel, like this video and share it to your friends. I'll meet you guys in the next video. Till then, take care.